everyone. We're going to find the limit. We're going to use L'Hopital's rule to find the limit as x approaches 0 from the right of tan of 2x raised to the power of x. So it has the form, if you plug in the 0, is 0 to the 0 power. So to handle this, we're going to take the natural log and set y equal to tan of 2x to the x power, and then take the natural log of both sides. Now when you do this, use your power property and bring this x in front. So we want to write it like that. All right, now that we have that, we're going to take the limit as x approaches 0 from the right of ln of y. And that's going to equal our limit as x approaches 0 from the right of x times ln of tan of 2x. Now, we're just going to concentrate on this piece here and write it in a different form. So we're going to write the limit as x approaches 0 from the right, and the numerator is going to be ln of tan of 2x, and then I'm going to move this x in the denominator by writing it as 1 divided by x. So that means we're going to have the form of infinity divided by infinity. And now I'm going to use my rule here, L'Hopital's rule, to find the limit. So let's do that. We're going to use L'Hopital's rule and take the limit as x approaches 0 from the right. So for the numerator, we're going to get 1 divided by tan of 2x times the derivative of the inner function. So that's going to be secant squared of 2x, and then derivative of 2x is 2, so I put that in front. And then for the denominator, take the derivative of 1 over x, that's just going to be negative 1 divided by x squared. All right, now let's simplify this as much as we can on this side. So we're going to get this equals the limit as x approaches 0 from the right. And simplifying this, let's see, I'm going to get 2 secant squared of 2x divided by tan squared of x, or tan of 2x. And I can move this x squared up front. So I'm going to put the x squared here for now. And it's also going to be negative. So that takes care of that. But what I want to do is rewrite my tan and secant. So this is going to be equal to the limit as x approaches 0 from the right. And if you rewrite all this, you're going to get negative 2x squared for these two pieces. And then we're going to deal with those two. So we're going to get, we know that tan is sine over cosine, and we know secant is cosine, 1 over cosine. So what we're going to get is this is going to be cosine of 2x divided by sine of 2x times cosine squared of 2x. And that's just simplifying my trig functions. All right, now let's look at what we have before I move on to the next slide. What's going to happen is I can simplify my cosine. We'll go into this one. There's 2 of them here. And I can rewrite this as the limit as x approaches 0 from the right. And I'll just have 2x in the numerator. And then the denominator is going to be sine of 2x. And then I'm going to split this up and write this as the limit of x approaches 0 from the right of negative x divided by cosine of 2x. So basically I just split this all up, and now let's take the limits. So for this first piece, this is just going to equal 1 times, and this piece is going to be 0. So this is going to equal 0. Now that is for the limit as x approaches 0 from the right of ln of y. Okay, so this equals 0. So now we have the limit as x approaches 0 from the right of our equation, tan of 2x to the x power. So basically, this is your y, but all we have is ln of y. So this piece here is your y. It's the way we set it up, but we only know ln of y. So I can write this as the limit as x approaches 0 from the right of e to the power of ln of y, because e to the power of ln of y just equals y. But I have the answer for this, and that is e to the 0 power, which equals 1. So the answer to our problem is 1. Thank you. Have a nice day. Bye-bye.